Okay, let's start.
Okay, thank you. Hello, good morning, everybody. Welcome to the Semantics iCargo webinar. This session is being recorded and will be made available at the iCargo website. So, just to clarify that this training session is about semantics, that semantics is just a part of iCargo. So other aspects of iCargo can be consulted at the training courses section of the iCargo website. At the end of this session, you will be available to ask any questions or make any comment you have using the chat window. Okay, so iCargo is a project partially funded by the 7th framework program. We are 29 partners for 13 countries. And iCargo will design and implement a decentralized ICT infrastructure, allowing real objects, new planning services and existing services to coexist and effectively cooperate at an affordable cost for logistic stakeholders. Okay. At this webinar, it is presented by myself, and I'm Marta González from Tecnalia, and also my colleague Matthijs Punter from TNO. This is the agenda. We are going to begin to explain why semantics has been applied in iCargo. We are going also to explain the different ontologies developed in this project and the different modules that make use of ontologies to work. At the end will be a summary and finally question and answer. So I think it's time for Matthijs to begin. Matthijs, we cannot hear you. Please activate the microphone.
If everything is okay, you can hear me now.
Thank you.
Okay, I'm sorry for that. So, what I was saying, if you look at iCargo as a project, it is about capturing all kinds of data from the logistic chain and using that information to do a better planning of your logistic chain, choose your transport services, handle exceptions more effectively, and above all also to look at the carbon footprint of it all, monitor it, and where possible to optimize it. Now, in order to do that, you need to have a lot of data that is coming from everywhere in the logistic chain. There are a lot of partners involved, and you can see just a few of the types of concepts and types of data that you require. Now, different actors in the logistic chains use different concepts for the same thing. They have different semantics. They use different standards to exchange that information. You have, it's not just one organization that has all the data, but it is a whole chain and network of organizations controlling the data. And different technologies are used for data sharing and exchange. So that makes it very difficult to get that integrated overview and to connect the dots together. This is also where the semantic challenge lies in iCargo, because we need to bridge the semantic gap. So we need to allow organizations to understand each other. We need to speed up the IT implementation. Of course, you can do system-to-system integration today, but it takes a lot of time and a lot of effort. And since iCargo is about business-level innovations and the ecosystem of organizations that collaborate, we need to also facilitate that ecosystem with technology. And then the semantic challenge or the semantic problem needs to be solved. Now, to give a little bit of an overview of that IT infrastructure that we're developing, we have a webinar that goes into this in much more detail. But the idea is that every organization in the business ecosystem can have an access point. An access point is a software module, very much like an email server. You deploy it once, and once you have it, you can communicate with everybody else that has an email server, or in our case, an access point. And you can use it to share data with others in a very secure and controlled way. But you only have to set it up once in order to communicate with all other organizations. Now, the data needs to come from somewhere, and we have a number of ways to do that. You can, of course, build an access point yourself and build a lot of IT around it. But we also have something we call mobile access point, which can be deployed on a smart device or on a sensor or maybe on an onboard unit or as part of an app. And it allows you to capture all kinds of data that is being produced in the logistic chain. And through your organizational access point, you can share it with others. We also allow, and that is something that we will focus on in this presentation, to integrate with existing systems that do not comply to these access point standards that we're developing in iCargo. And we call it the semantic gateway because it allows you to connect existing systems, existing databases and so forth that might use traditional ways of communication to integrate them in the iCargo world. But very much like an email server, if you take the iCargo access point, an email server knows how to send emails, but it does not determine the contents of your email. For an access point, it is the same. We have a standardized API, which is based on REST, to communicate between these access points. But still, you still need to define the semantics of the information that is being exchanged. Now, to do that, we use technologies from the semantic web, in particular ontologies. Ontologies are models to capture semantics. They are very suited to deal with huge quantities of heterogeneous data. So it's also coming from the world of big data and the semantic web. And they allow us to configure these access points, to provide them with a computer interpretable model of the semantics of the data that is being exchanged by that access point. And again, we use the semantic gateway to connect with other systems that do not support this world. So focusing on these ontologies, in iCargo we start off with something we call Logico, which is a logistics core ontology. So we do not start from scratch, but Logico provides you with a collection of commonly used concepts in logistics. We developed it in the iCargo project in parallel to the Cassandra project, which is also an EU FP7 project focusing on logistics, but with a more customs and compliance point of view. And this ontology provides you with a range of concepts that are relevant for logistics, like orders, like transport equipment, and so on. And you can use that ontology to connect existing models to one another. For example, you could have model A that says it's about trucks. You can say, well, a truck is transport equipment. Model B is about ships, which are also transport equipment. And you can use Logico to connect the two together. And in that way, we can assist in bridging the semantic differences between various organizations providing various information. You could also use this core ontology to develop a new model for your own. So if you want to say, I have data about my transport orders in a particular domain, and I want to share it through my access point, you can use Logico to specify the data that you would like to share with others. And it is used to configure your access point. But as I explained before, we're not only dealing with this world of iCargo access points and their specific API, we're also integrating with existing systems that might use, for example, XML messages to communicate. So what the technology allows us to do is also to create mappings between these ontologies that are used to configure an access point and messages. So you know that when a message arrives, that it relates to a certain concept in your ontology, and you can interpret the semantics of it. This is what we use in the semantic gateway, and Marta will explain that in more detail in a moment. Now, apart from Logico, which is a collection of concepts, we're also using something that is called a common framework. And the common framework is a reference model. It was developed through various EU research projects for logistics. And it basically describes roles, business processes, and information models used in logistics. In fact, it contains an information model. Until now, this was a UML class diagram. So it was a diagram which was not computer interpretable, but it, of course, was very much usable if you want to configure your systems. It specifies the processes and interactions between the various roles in the logistic world. For example, how to handle a transport order, a booking, how to send transport statuses, and it also provides us with XML messages to deal with these interactions. Now, we use the common framework in iCargo as a reference model. We have a number of business level innovations, and we've specified them in terms of the common framework. So we have a standardized way of integrating various end-user applications that are also being developed in the project, and say, this is, for example, how chain composition works, and these are the interactions that are used there. And that's also something new in iCargo. We've built an ontology for this common framework. So now, for the first time, we not only have an information model on paper, but we also have an information model that is computer interpretable and that can be used by, for example, the semantic gateway to interpret messages coming in. So in summary, we have Logico, which we can use to configure an access point and specify the semantics of the data that is being provided by a certain organization. And that data is then exposed to the iCargo ecosystem for others to use. And we provide a mapping to the common framework model. So we also have a reference implementation and messages that can work with end user applications. Now, with that, I would like to hand over to Marta to go in more detail about this common framework and also to show how this works with the semantic gateway. Marta?
Okay, thank you, Matthijs. And as Matthijs introduced the common framework, this reference model was developed because the transport and logistics sector is so extensive and complex that a division into manageable domains is a necessity. So the common framework for ICT in transport and logistics is a holistic architecture describing roles and responsibilities, business processes and information models relevant to the transport logistics sector. The common framework reference model decomposes the entire transport and logistics domain into manageable subdomains, each of them addressing responsibility areas. These interfaces or information models are described using UML class diagram, XSV schemas, and XML examples. When trying to develop the common framework ontology, we were focused on the interfaces or information models. The different interfaces that was implemented was the TSD, or the Transport Service Description, that enables a logistics service provider to announce her transport logistics services to one or more clients. The TEP, or the Transport Execution Plan, this is a plan for logistics services established jointly between a logistics service client and the provider. Then the good items itinerary specifies the route and the time schedule for a transported item, and the transportation status messages that provides the status of a logistics service covered by a transport execution plan. This information model or interfaces make reference to near the 90% of the whole concepts described by the common framework. Also, it has been implemented the different code lists for different concepts as cargo type, environmental emission, or transport equipment, among other 27 different code lists. So this is the common framework ontology, and in order to develop this ontology, we followed the network ontology approach, because we decide to reuse state-of-the-art ontologies as much as possible. We select these two ontologies, attending to criteria as that the knowledge domains formalized by each of them cover a subset of the knowledge domain of the common framework, and the selected ontologies be successfully applied in other environments. So we decide to reuse the Proton-T ontology, that is a lightweight upper level ontology, because it has been used with success in other domains, as with ERP integration and knowledge management process. We also use the all-time ontology, that is the ontology proposed from the W3C, and it provides a vocabulary for expressing facts about relation among instance and intervals, also about date and time information. So the different messages that were included in the ontology was the already mentioned, the transport service description, the transport execution plan, the transportation status, and the goods item itinerary. And we are going to see how each of them are formalized using the UML, okay, in the common framework reference model. And this is the corresponding ontology to such UML model. In this case is for the transport service description message. This has been done the same for the transport execution plan, that make reference to different elements as transportation service, the contract, the consignment, the different shipment stages, and so on. And this is how the ontology has been formalized attending to such model. In the case of the good item itinerary, it has been made the same. This is the UML format, and this is how it has been formalized as ontology. And to finalize with the transportation status message, here you can see the UML format and how it has been developed, the ontology. So now we are going to talk about the different components that has been developed in iCargo, making use of the different ontologies. So this is the semantic gateway that Matthijs has already introduced. This module allows external companies to the iCargo ecosystem to exchange messages with the companies compliant with such ecosystem. The semantic gateway abstracts users from the underlying ontology and the necessary technology to support its operation. The approach has been designed considering the case in which several companies are collaborating in a virtual community. This community is built around a commonly agreed information model. The semantic gateway enables external companies to offer their services to this virtual community without altering the common data that are served at such a community. It takes as input the common framework messages, interfaces or information models, as well as other kind of messages, and translates them to the common framework ontology, offering separate query endpoints to query information contained in such messages. The link software module makes use of the semantic gateway, but it enriches a shared common model with inferred knowledge for incoming common framework messages and user-defined rules. From the model, the link software module extracts knowledge to be used in the creation of new outgoing messages. This module is intended to be used by a virtual community, as explained before, where the arrival of a new message modifies the shared data. The architecture that supports the link software module is the following. It offers REST service for a new message appearance. The message is translated by the semantic gateway to RDF in an intermediate repository. Over the intermediate repository, the information is processed in order to be incorporated in the knowledge base served by the ecosystem. The information in this knowledge base is offered by means of a Sparkle endpoint that is inside the access point. So let's go with an example. Suppose this situation where there are a number of entities in the common framework ontology served by companies in the iCargo ecosystem. These entities exist, but they are disconnected. But a message arrives. A message with transport service description saying that a specific cargo will be carried by a certain vessel from Bilbao to Rotterdam and from there by plane to Singapore. The link software modules treat it, modifying the common ontology, resulting in that the disconnected entities are now connected. The different shipment stages are established, and the total environmental emission is calculated. Just to finalize, I would like just to summarize what we have been talking. Just to clarify that the transport logistics chain, as you know, is made up of actors using their own information systems for its daily management. Although several standards from the logistics world are used for message exchange, there is still a need of agreement on using the same language while preserving the internal way of operation at each company. The solution to this need opens a new horizon in providing access to information in a common language, taking advantage of existing standards. This common language will allow deploying real-time cooperative planning algorithms to find the best route attending to criteria such as the most green, quick, economic, and/or safe route, as well as algorithms able to react to real-time events as delay, accidents, breakdowns, whatever. So, a common language, the common framework for ICT in transport and logistics, was developed. How this language is implemented by ontology means, and the development of ontology-based ICT tools has been explained, as well as the logical ontology. So we think that the ontology-based ICT tool allows the creation of an environment where transport logistics chain actors remain using their own information system while they are real-time situational aware. We think that additionally we are providing a low entry cost interoperability solutions because we are avoiding the use of costly shared and centralized ICT infrastructure usage. So I think it's time for, if you have any questions, please feel free to ask. You can use the chat window.
Yeah, maybe this is Matthijs again. We in this webinar, since we just have limited time for this, we provided an overview, and through the iCargo website, more documentation and background information is available on these things.
Well, I will answer to Idoia. Idoia is asking if we are using some automatic tools to transform UML to the ontology, but we decide not to use such automatic tools because sometimes the semantics of the domain is lost. So we decide to, in collaboration with people expert on the common framework, we decide to do it by hand, I can say. Who should counter? I think Matthijs?
Yeah,
Perhaps I think Andreas is asking about the needed agreements for entity collaboration and for guidance.
yeah, maybe I can take a few of these questions. I think first of all, there's the question of Andreas Meingast regarding the rights management. Of course, that's a very important topic. Yeah, we'd like to share information, but you would like to do it in a controlled way. So that only maybe your direct business partners have access to the data, and maybe not your competitors, while other data might be more publicly available. This is something that is covered. It is covered as part of the functionality of an access point that facilitates this rights management. And there will be a separate webinar that goes into more detail about how an access point functions and how it publishes the data and exposes the data to others. And then the question of Andreas, who should, can, may run this system. It is designed in such a way that it can be run actually by everyone in the logistic chain, because we can support the whole range from the very large back-end systems until the situation where you have one truck and just a smartphone, and everything in between is possible to cover with the technology in iCargo. Furthermore, and that's also part of the business perspective of iCargo. We said, okay, as such an access point, it can be deployed as a software module by an individual company, but it can also be provided as a cloud service by a third party, maybe a party that does this on behalf of a community as a whole. So we have different models on how to provision these types of solutions. So, can see a question, maybe I should take that one as well, from Utsa on the two ontologies.
Well, we can share the answer if you want. In this case, a common framework ontology models information exchange when performing function and processes in the transport logistics domain. That logical, Matthijs?
Yeah, Logico takes a more general approach. The common framework is a reference model. It describes roles and processes and the interactions. But of course, there are also situations where you cannot comply to such a reference model because you already have models in place or because you have a specific need in your business. And that is why we have Logico, which is merely this collection of concepts, so it's more general, and we have the common framework, which is much more specific and really is a reference model for logistics as a whole. And what you also see is that Logico is not only used here in the iCargo project, but also in the Cassandra project, where it is used for interactions between businesses and customs and other governmental organizations. So there are different uses there. Maybe we should take a question of Andreas as well, Andreas Meingast, on how long it takes to set up or configure such an access point regarding fast-changing stakeholders. Well, this is exactly the thing that we are looking for, because to speed this up. The issue nowadays is that if you want to do business and you do this in a fixed relationship, of course you have some time to set up things like EDI connections, but in the more collaborative environment that iCargo envisions, you want to do this in a much more dynamic way. So of course still there is some time needed to initially set up your access point and to configure your data, to connect the systems, to configure a semantic gateway, maybe also to do some system-to-system integration between access point software and other back-end systems. But once you've done that, the idea is that not only for long-term fixed relationships, but also for much more dynamic relationships. And because you only have to do it once, it saves you a lot of time. But we're still, unfortunately, I can't give you any specific figures on this, because in iCargo we're not only developing the technology, we're also doing some pilots. I think we also have some videos on that available in a while. And of course, well, these pilots are also used to demonstrate how easy it is or not to do this.
Mm-hmm. Thank you. And yes, the last question from Andrew: are there any fundamental international standards being applied? In fact, the common framework, it seems to take the best of everything, but there are any other projects that has been in charge, for instance, to translate for GS1 or UBEL or ECPIX or whatever to the common framework. Okay, so you can launch a message in such a standard and can be translated into the common framework.
Yeah.
Well, I said the last one is need to make changes. Okay. The idea is that, the last one, Iñaki asks, it is needed to make changes to our internal systems to be able to talk inside the iCargo ecosystem. The answer is no. In this case, if you are not using you have not an access point, you are an external company, you can use the semantic gateway, for instance, to translate the messages, even to expose your databases and so on. So I think we are going to close the webinar. I would like to thank each of you for attending. Thank you. A lot of people hearing us. Thank you. Thank you. Enjoy the day. I hope the summer. Goodbye.
Okay. Thank you very much. Bye-bye.
Bye.